Welcome back to Connect and Transform. In this video, I have extended the graphing SVG project. And so I'm going to talk about that, and then I'm going to talk about why it's probably not the correct solution. After I wrote the code about 10-15 minutes ago, I thought of a better way to do it. And so I've already obsoleted what this video is about, but since the code is done and it does work, I'm going to present it here. So a quick refresher, since it's been a few months since we've worked on this project, there's a number of different graph types. This is area at the top, stacked area, bar, stacked bar, line with colored regions in this case, stacked line, scatter, and then at the bottom is pie or donut. So there's a lot of different varieties. And in the original project, we wrote a function that if we were to click on the series legend, the color box, or the labels, that it would bring that series forefront in the z-axis. So for example, right now, purple is at the forefront of the z-axis, and if I click on this green one, now green is at the forefront of the z-axis. So that works great for a non-stacked variety. The problem is that these stacked varieties, even though it is technically bringing this series to the forefront, it's bringing it to the forefront of the z-axis rather than reordering it on the y-axis. So there's no visual change, even though it is technically changing. And so what I did for this video is I wrote some code to change how the stacked bar variety will behave so that when you click on the color box or the series label, it pushes that series all the way to the bottom. And then, for example, if I push this blue one to the bottom, we also need to raise or lift the two purple series upward by a certain amount. So I'm going to go ahead and click that, and we can see that that does happen. And we can also see, for example, if I push this one downward, nothing above it needs to be touched or changed. And we see that that is also true. Nothing above it changed. So we see the effects of a functional working bit of code. I'll briefly talk about it, but not too much because I don't think it's the correct solution. So why is it not the correct solution? Because for stacked line or stacked area, using the approach that I'm about to show you, I would have to write a separate function for each of those three stacked varieties that are specific to the types of SVG elements, the polygons in this case, the rectangles, bars in this case, and the line segments and invisible circles in the case of a stacked line chart. And so these three functions would be very different and very specific, open you up to more bugs, open you up to yet another thing that has to be maintained in the future. The alternative, and the thing that I didn't think of until a few minutes before this video, is when I click on the color box or the series label for a stacked type of chart, the graph data is already in JSON form. So all I have to do is reorder the array of the data series and then reload the data series. I don't even have to reload the entire graph, and I'm thinking that I should not load the entire graph again. For example, I don't have to take time computing the axes or the axes labels or probably even the tooltips. And I probably also do not have to recalculate the colored regions if I'm not rescaling or recalculating the axes. So all of these things could stay exactly the same and still function as they should. The only things that would need to be reloaded are the actual data series in the region of the chart, and then possibly also reloading the series legend itself, so that, for example, if I click on this blue one, and let's say I shift the blue one all the way to the bottom, it would probably make sense at the very top here for this legend to also reorder to match the data series order. And so I would probably reorder both. But I'm going to try a couple different things in the next video and see what works. And if it works, we'll go with it, and if it doesn't, we'll scrap it. So this is the code that I wrote that I was going to talk about in this video, and now I believe I'm going to scrap all of this code. But because it works, let's talk about it really briefly. So we're showing the before and after in a text comparison tool that we wrote as another project in a prior series of videos on this channel. Feel free to check that out if you're interested. But you can see that before, we just had the 2 lines of code on the left, and then after, we kept those 2 lines of code, and we just added some additional ones. So this is all inside the function that runs when we click on the series legend elements. And basically what we've done is we have an if-else statement at the highest level saying if it is not of a stacked type, then we want to keep doing what we were doing before because it works. So for example, up here at the very top, this is not a stacked type, and it is already doing what we want it to do. So we can keep that the same. Now we might change this behavior if we're going to be doing a more generic function, but let me continue talking about the function that I wrote. So the function that I wrote has 2 arrays of data that we're keeping track of. We're keeping track of the offset and of the height of the series that we clicked on. So why are we doing that? So let's say we're clicking on this blue series to push it downward. So we need to keep track of the height of each bar to know how much to pull upward every series that's visually below it. So for example, if I click on this blue series, then this purple series here needs to move upward. But by how much? Well, precisely by the height of this series. Now, that's not always going to be the case, because what if I click on this green one? Well, then every series below it is going to shift up by the height of that bar. But then we also need to keep track of the offset. And why do we need the offset? Let's think of one that's in the middle rather than one extreme or the other. So let's look at this blue series. Everything visually above it, everything that has a smaller y attribute value, doesn't need to be changed at all. And so that's why we're keeping track of the y offset, is to know which series we need to modify and which series we don't need to modify. So in the case that we are looking at a stacked graph variety after we've initialized our data arrays, then basically we have an if-else. So we're saying here, if it is the one that we clicked, then we're going to push it all the way to the bottom. And so we're basically saying we're going to set the y attribute to the initial y offset, which would be all the way down at the x-axis, but then we're subtracting out the height of each individual data node itself, because the y attribute refers to the top of the bar rather than the bottom. And then we have an else statement here. So otherwise, if it's not the series that we clicked on, then we're going to say if it is visually lower, in other words, if it has a larger y attribute value, then we're going to raise it upward by the height of the series that we clicked on at that same index. And so that's basically what the code is doing. But I'm not going to get too much into the details of the actual code, because again, I don't think this is the correct solution, because this would require 3 very different and very specific functions, this only being one of them. This is only the stacked bar solution. It does work, but it's a messy solution. I'm going to go back in the next video and we're going to try to solve this in a more generic way, where we have one piece of code that can be applied to the stacked bar, the stacked line, and the stacked area, without getting into the details of how those things are visually presented. So I'm looking forward to that. I hope you are too. Thanks for watching.